Okay, here's the second part of this 3D trig. It says we're supposed to show that MQ equals K times the square root of 1 plus 8 sine squared theta. Ooh, that's a pretty messy looking thing. There's a bit of a hint. A lot of these 3D trig things just use the sine rule. But if you see a square root and a bunch of junk like this, you're almost certain you're going to have to use the Cos Rule. And if we're trying to figure out MK, and we've got two sides, and we know this angle in between is 2 theta, then it must be the Cos Rule. It must be the Cos Rule. So that's what we're going to do. We're going to go MQ squared must equal K squared plus 2K squared minus 2 times the two sides multiplied together times the cosine of the angle in between. That's the Cos Rule. It's kind of like Pythagoras, a squared plus b squared, but there's this little minus 2ab times the cosine of the angle in between. There's your little correction factor. Well, now we just got to do a little algebra. We got 2k times 2k is 4k squared plus k squared. That's 5k squared. 2 times 2 is 4, and it's k squared. Now that k squared, if we factor it out, look, there's a k by itself. Let's factor the k squared out. Then we'll have 5 minus 4 times 1 minus 2 sine squared. Well, what's 5 minus 4? That just equals 1. And what's minus 4 times minus 2? It's plus 8 sine squared. Oh man, that looks almost exactly like it. All we got to do is square root it. And that's it. We've got it. MQ equals K times the square root of 1 plus 8 sine squared. That's what we're supposed to show. So most of the time it's sine rule, but look at this. They threw Cos Rule at us, and we've got two sides and the angle in between. And you kind of have to know that's when you use the Cos Rule. And that's why we set it up like this, or why we used it. And look, it all fell out and gave us the right answer. So there you go.